Welcome to Class Time, your daily classroom for CSEC students.
Today in math, we'll be looking at appreciation and depreciation. I am Latoya Shiraya.
And I am Karima Mundell Thomas.
Let's get right into it.
That's right, Latoya.
All right, so we're looking at appreciation and depreciation, but of course, before we go into, we have to define what appreciation and depreciation is. So what do you think is meant by appreciation?
I'm not sure. I'm thinking about English, and I know that them say you must be appreciative of things. So, I wonder, it have nothing to do with gratitude, me no know. Tell me.
Not necessarily, but when I tell you what it is, you're going to be grateful. All right, so appreciation refers to when the value of something increases over time.
Oh.
Right, so the value of a house usually increases over time, and I'm sure you'd be grateful for that if you own a house.
All right, makes sense.
And so we will therefore say that the value is said to appreciate, right?
Cool.
So the value of the house is said to appreciate.
Interesting.
All right, so we know what appreciation is. What do you think depreciation is now?
All right, so since appreciation has to do with the value of something increasing over time,
right,
I'm going to say depreciation must be when you have the value of something decreasing over time. Sounds like opposites to me.
Excellent, and they are exactly that. So depreciation refers to when the value of something decreases over time, and I'm sure we don't appreciate that. So for example, the value of a car is usually decreasing in value with time, and therefore its value is said to depreciate.
You know, Latoya, interesting that we're doing this topic today because many times, you know, as parents tend to encourage their children, you know, to go and put all of your money in a car. It better you invest in our house, you know?
Right.
And I never really quite got it until today, because I noticed you said that the value of a house or property, or I'm going to extend it to land,
definitely
tends to increase over time.
Of course.
A car, though it might be flashy,
nice,
you know, today nice, comfortable, after a while with the wear and tear, it's going to devalue.
Definitely. So whatever value you would have purchased the vehicle for, when you have to resell, you will definitely get less. So you won't make any profit, so to speak, but a loss.
So it makes sense then to really invest in things that appreciate.
Definitely.
I agree.
And since you said that, I'm going to show you some things, and you're going to tell me if they appreciate or depreciate. Ready?
All right, I think I can do that.
All right, so the first one is stocks.
Stocks. Well, I think we also get encouraged to invest in stocks too, you know, because, you know, they say that you can earn over time.
Definitely.
I would say appreciate for sure.
Definitely.
All right.
All right, what about gold?
Precious metal, rare. I'm going to think, well, I'm thinking gold appreciates too because, you know, you watch some movies, you watch them movie like
Pirates always looking for the treasures and
Not
stuff.
just that, but people tend to store their wealth in gold bars or that kind of thing. So I want to think that appreciates.
And I would want to think that the cash for gold people appreciates the gold, right? All right, what about jewelry? Excepting gold and diamonds, of course. Regular jewelry, like your little watch and such-ins and your little ring and your little fashion chain and so.
Depreciate.
Definitely. All right, what about cryptocurrencies? And cryptocurrencies are like, I don't know if you've ever heard of Bitcoins. So it's not physical money, basically. So you know, like you have the Jamaican dollar and the US dollar physical. It's a currency, but it's not physical. Virtual?
So, I'm one of those persons who are not so familiar with the cryptocurrency, but if you say it's not real money and it's kind of virtual, I'm going to make a guess. I'm going to think that this appreciates.
Definitely.
All right, cool.
All right, what about furniture?
No, Latoya, you have to clarify that. You have to clarify that because...
All right, tell me what you're thinking, though, before I clarify.
If I have an antique furniture, right?
What do you mean by antique?
All right, so it coming down my generation from a great grandmother.
Right.
Who probably did all famous.
All
So
right.
that piece of antique furniture with time would actually appreciate in value.
Okay.
But, you know, your little dresser or whatnot, you know, we're having a little house like all mine at home now. I would say those depreciate.
So you're right. It depends on what kind of furniture. So if, say, for example, the Queen of England or Beyonce happens to be your great-grandmother, then the furniture from those homes will definitely have lots of value. But like our fridge, we're not famous yet. Yeah, they're going to depreciate.
Fine.
All right,
We'll
and finally, equipment.
Well, equipment, I'm thinking something that probably is used in maybe a company, manufacturing probably, or something like that. And, you know, over time, those, I think, would depreciate.
Definitely.
All right, cool.
So we can identify things that will appreciate and depreciate. So let's move into a question then.
Cool.
All right, so Miss Ivy bought a piece of land for US $1,000, sorry. How much will the land value after 3 years if it appreciates at a rate of 10% per annum? And just to zoom in on per annum, when we talk about per annum, we're talking about annually or yearly, per year. So that's another phrase to represent yearly, right?
All right. So based on this question, Latoya, Miss Ivy's piece of land, she bought it for US $1,000,
Yes.
right? And we know, we spoke about this earlier, that land, the value appreciates.
Definitely.
And so it's said to appreciate at a rate of 10% per year.
Yes.
So that sounds like 10% is being added on to it each year.
Right.
And we want to know 3 years' time
How much money
Miss
the
Ivy's
land gonna worth, right?
All right. So sounds to me like since the 10% is being added on, next year it may be 10% of whatever it is.
Right, right.
And then the following year it's 10% of whatever it value at that time.
Right, right.
Sounds like we're gonna have to do it year by year.
Definitely.
All right, so let's see what we have here.
So as you rightly said, for year one, the value of the land would be the current value, which is $1,000, plus 10% off that $1,000.
All right, and let me just go to the board quickly so we can talk a little bit about how we calculate that 10%.
Okay.
So remember that 10% is actually 10 hundredths.
Right.
So if we're writing 10% as a fraction, we would have 10 as our numerator and 100 as our denominator. And we're finding 10% of $1,000.
Right.
And of course, we can find common factors. So 10 into 10 will go 1 time, and 10 into 100 will go 10 times, and 10 into 10, 1 time, 10 into 1,100 times. And so we would have $100.
Indeed. And so the value after 1 year for Miss Ivy's piece of land would be $1,100.
All right.
So that's year one. So at the end of year one, the land is now valued at $1,100.
All right, cool. So we need to calculate year two now. So based on what we said earlier, when we're going to calculate year two, we have to use what the land now values.
Precisely.
So it now values $1,100.
Right.
And it is this that I'm going to use now to calculate the 10%, which needs to be added on to its current value.
Indeed.
All right,
excellent. Cool. So I just want to reiterate that we are using what the value that the land currently owns in year two. So it no longer values $1,000, it now values $1,100, and that is what we are going to use to calculate our value at the end of year two. And when we find 10% of 1,100, that will give us, that will give us $110. And so at the end of year two, the land now values $1,210.
Look at that. Can you see that increase taking place,
I
Latoya?
am seeing it, and I wish this was my piece of land or Miss Ivy was my granny.
Can I tell you?
All
Year
right.
3.
And we follow through.
Right. So at the beginning of year 3, the land would value 1,210.
Right.
And so we're now finding 10% of that, which is going to be added on in this year. And 10% of 1,210 is 121, thanks. And when that's added to the 1,210, Miss Ivy's land after 3 years would value US $1,331. But you know, that was a whole heap of work. Suppose Miss Ivy wanted to find out how much our land value after 10 years.
I was just about to say the same thing. Like, if I were Mr. Ivy's accountant or realtor, then, oh my, I would have to sit down and work out all of this.
For every single year, there must be an easier way or a shorter way. Let's see if we can explore this a little bit more. All right. So Miss Ivy's land valued US dollars 1,331, right?
All right. So
that's US dollars.
I know that in math we always can find a formula for everything. Or not for everything, but
most things.
We can find a simpler way to do things in math all the time. So I'm now looking and I'm trying to figure out what are the similarities in each year in our calculation and maybe think of how we can put that into a formula. So I'm seeing definitely 10% each time.
All right.
So that's constant.
Let's see if we can examine it a little bit closer.
All right.
See if we can derive this formula for appreciation. So when we looked at year 1, right, we know that the land valued $1,000, right? That's the starting value there, right? And this original value or this starting value is representing 100%, right, or the whole. Good. And then this 10% is the appreciation, and so it is being added on to that 100%. So I'm thinking now, based on what we calculated earlier, that this land is now, at the end of year 1, going to value 150%. 110% of what it valued at the beginning.
And technically, each year, it did value 110%.
Of what it valued at the start of that year. But I want to take it a little bit further, because that 100%, we can always write that as a fraction and ultimately as a decimal. All right? So that 100% we know is 100 hundredths. In other words, we're dividing 100 by 100, and that's equal to 1. And of course, 10% is 10 hundredths, which when we divide 10 by 100, the result is 0.1. All right.
So we can rewrite this, so we're working with some smaller numbers.
But with the same value.
Definitely.
All right. So $1,000 here. And in our bracket, we have our 100%, which we just found out is equivalent to 1 if we're writing it as a decimal. And 10% is equivalent to 0.1 as a decimal. So now when we add these two together, we're now getting 1.1. And it is that 1.1 that is going to be used to multiply 1,000. Let's see what the result is. Wasn't that what we got earlier?
Yes, indeed. That's what we got.
Cool. Now, you mentioned something earlier, because you were saying throughout the calculations, you noticed that we kept adding on that 10%, right? So we started with 1,000, as we're seeing on screen. We multiplied by 1.1, and we got 1,100.
We did.
And then for year 2, it was that 1,100 that we multiplied by 1.1, and the result was $1,210.
It was.
Yes. And then...
So you're telling me if I multiply this by 1.1, I'm going to get $1,331?
Yep.
I don't believe.
That's it. Perfect.
Wow.
Perfect.
Okay.
So can you see that we started with that $1,000, which was the value of Miss Ivy's land when she bought it. And through those calculations, we notice we're multiplying by 1.1 each time.
Technically, yes.
So I'm seeing something looking
Familiar.
like...
indices, no, yes, no, yes.
Well, it's repeated multiplication, and we know that we can represent that using
an index.
Indices. All right. So then, we notice here that this 1.1, look at the index that's there now. That's 3.
That's a number of years.
So we need to make that connection because the question asked us for the value of Miss Ivy's land after 3 years. Good?
Okay, I'm seeing the connection here.
Good.
So I'm seeing my 110% and I'm seeing my 3 years. Okay.
And you're seeing your present value, which is what you started with, that $1,000.
And then the future value after the 3 years. Yes, I'm seeing
that
it.
$1,331. Good. But I want to point out something, Latoya, in that third line on screen where we have that 1 being added to the 0.1.
Yes.
I just want our students to remember that when we talk about appreciation, we're saying that the value that you start with, okay, that's representative of 100% or 1. Right? And so that's always there because it is this that we're going to be adding on to.
Right.
So if we're to transcribe, for want of a better word, what we have on screen into a formula, because we don't want our students to think it's always going to be
10% or always 3 years or always $1,000 ending up with always $1,331. Whew.
Right.
All right.
So some of these values will change, but we wanted to point out that that 1
will remain constant.
Right, because it's representing the whole that we started with.
All right. So you're saying that the $1,000 in this case is representing of the present value, right?
Or initial value. Our students may see that in some books.
And then our 1 will remain constant.
That's right.
And then our 10% representing 0.1 in this instance will be our rate of increase because you're looking at appreciation, so there is an increase.
Right, and it's usually given as a percentage, so you may wonder that 100 there, it's there because the rate is normally given as a percentage.
All right, and then our index here representing N will be the number of periods, and periods, I'm thinking it won't necessarily be years all the time, it could be monthly. Or biannually.
That's right.
All right. And then our final figure is our future value.
That's right. So I think we have ourselves a formula. What do you think?
I think we do.
All right. So now that we have our formula for appreciation, there must be a formula for depreciation as well.
I think so too.
And you know.
But hey, I have a brilliant idea. Seeing that appreciation refers to an increase and depreciation is a simple opposite, which is a decrease in value.
Yes.
I'm seeing an addition sign representing an increase. So I'm just going to boldly say I'm going to use a subtraction sign to represent a decrease.
That is very bold. But you know what I think about? What if Miss Ivy had purchased a car instead of a piece of land? You know?
Yeah.
And it's losing that 10%. Then that 10% could not have been added onto its value. It would actually have to be subtracted from its value.
Agreed. So it's no longer 100%, but it's now 90% if it's depreciating.
If it was 10%, yes. And so, you know, I want our students, because we're going to go to a break in a few seconds. So I want our students to just capture this, and we're going to see if our boldness or our logics really works.
So we would have proved that the appreciation theory actually works.
Our formula, yes.
And the formula, rather. And so we are going to now prove if the depreciation theory works.
That's right.
All right?
So we made some bold
I did.
Logical thinking.
Definitely.
And we want to just test to ensure that what we said is actually correct.
Right. All right, so here's a question. The value of the machinery in a manufacturing plant depreciates at a rate of 8% per year. If the original value of the machinery is $65,000, find its value 4 years later. So before we get into the formula, let's do it the long way.
All right, no problem. Quote unquote.
Yeah.
Yes.
Just
so we're going to be working each year.
Definitely.
Cool.
All right, so for year one, as we would have said before, when we talk about depreciation, the item, in this case the machinery, would be losing value. And according to the question, it's losing 8% of its value each year. And so we would find 8% of $65,000 and subtract that from the $65,000, and that will give us...
So 8% of $65,000 is $5,200.
Right.
Once we subtract, after year one, the machinery is now valued at $59,800.
See now, very big decrease.
Well, let's see what
already
happens in year two.
All right. So we're taking the current value now, which is $59,800, and we're subtracting 8% of that from it. 8% of 59,800 is $4,784 dollars. And when we subtract, the machinery now values $55,016.
Wow.
All right, what about year two?
Year three now.
3.
So for year three, again, the machine now values $55,016. We're asked to take out 8% of that, right? 8% of $55,016 is $4,401.28, which means at the end of year three, the machinery now values $50,614.72.
This sounds like it's a walker or a lawnmower. I don't know.
Wear and tear, girl. Wear and tear. Talk about year four.
All right, so continuing on the same trajectory, year 4, we're taking the present value of the machinery at the end of year 3, which is $50,614.72. Finding 8% of that and subtracting it. 8% would be $4,049.18. And at the end of 4 years, the machine that was valued at $65,000 now values $46,565.54.
Wow.
So I wanted to remember this value in your head, you know. $46,565.54.
All right, cool.
So we're going to use the formula that we derived, and we want to find out, or see, prove, if you will, that the answer will be $46,565.54. 54 cents. All right. So here's our formula, and
let's talk about what we know. So based on the question, the value, or the original value of the machinery is $65,000.
Right, and our PV, present value.
Good. We're told that the rate of depreciation is 8% per year. So our R value here is 8. You might notice we don't have the percent on because the 100 is already in the formula.
Right.
So R is equal to 8. And N, which represents the number of periods, in this case we're talking about years, so N is equal to 4. Pretty much we're going to be using our algebra skills, yes.
Substitution.
Substitute, that's right, the values in our formula. So if you notice where present value is, we have substituted $65,000. Where R is, we have substituted 8, and where N is, we have substituted 4.
So in using the formula, you simply pick out the information from the question you can identify.
That's it.
And substitute.
That's right.
And then simplify.
Beautiful.
That sounds like
And
3 steps.
You know,
to me.
I want to point out, remember now our focus is on that subtraction that we talked about when we were deriving the formula. So as we look at the third line that we have on screen, we're seeing now that 0.08, that should be 0.08 is subtracted from 1. All right, so there's a typo error here. Just want to point it out. So it's 1 subtract 0.08 raised to the 4th power. All right, and so we have 65,000 here being multiplied by 0.92, which is raised to the 4th power based on the question. So our final answer, future value here, value after 4 years, is $46,565.54. Sounds like the same value that we had.
It is.
When we used the quote-unquote long way. You said that. So it works.
It does.
I feel great.
Me too.
Good.
All right. So here we have a CSEC question from the May 2004 paper. And it reads, Mr. Williams bought a plot of land for $40,000. The value of the land appreciated by 7% each year. Calculate the value of the land after a period of 2 years. So we're going to use our formula, but first let's pick out the information that we can gather from the question.
All right, cool.
So clearly we can see that the present value of the plot of land is $40,000.
That's right.
Our R rate is 7, and the N is the number of years, which is 2. All right, so now we're just going to substitute those values into our formula. And voila. And after you have substituted, you want to simplify, right? And see, we're having inside of the bracket 1 plus 7/100 is now 1.07. Same 7/100.
I want to point out something, Latoya, as I'm looking in that bracket where we have that 1.07, I'm seeing the increase right there.
Right.
Yes, because remember your starting value would have been represented by that 1,
right.
100%, which is 1 as the decimal. And I'm seeing literally that 7% added on. So that value is actually greater than
the
1.
Right. And so after 2 years, our piece of land, or Mr. Williams, not mine, plot of land would now value $45,796.
Okay, so it means that this land would have gained $5,796 in value.
Mm-hmm.
Yeah.
Holy cool. Money that in 2004, you know.
That is why when we started, I said we must choose wisely what we invest in.
I need to call a realtor right after this.
There you go.
All right. Now, the May 2006 paper also had a question with appreciation and depreciation. And, sorry, for this question, it gave a table with some values and some missing ones too. And it says, the table below gives information on the values and the rates of depreciation in value of 2 motor vehicles. So from our table, we're seeing that we're seeing a taxi and a motor car. The taxi initial value or present value
yes.
would be $40,000, while the private car would be $25,000. Dollars, thank you. The taxi was depreciating at a rate of 12% per year, whilst we need to find clearly how much
what's the rate of depreciation
for
per
the
year
private car.
Right.
We we're not given the value, so clearly we need to find the value after 1 year for the taxi, after it would have depreciated. And they also told us that the private car's value after 1 year would have been $21,250.
That was a lot of word. Good
Holy.
thing that it's captured in a table.
Yes.
Yes.
I see why they put it in a table. It would have been a lot of words.
Right.
So the question asked us to find the values of P and Q and then the value of the taxi after 2 years.
All right.
That doesn't sound odd. So we're finding the value for P first.
Yes. So P has to do with the taxi. And based on the table, we can, of course, it's even easier to pick out those values that we know.
Right.
All right. So let's talk about what we know. We know, of course, the present value. You may not see present value on the table, but it's the same as the initial value of $40,000. Our R here is 12, which is coming from the 12% yearly rate of depreciation. And the number of periods, in this case, it's years we're talking about, is equal to 1 because we're finding the value after 1 year.
And I would want to point out to our students that you have to focus on the question because there is a 2-year question there, but that's not the question for this question. We want to find out P, which is the value after 1 year. All right? So we're now going to substitute our information that we took from the table, very visible there, into our formula.
And again, ensure that you're using the correct formula.
Right.
So the question is speaking about depreciation.
Right.
And so we're just double check to ensure that you're actually subtracting the rate from that one.
So we just want to make it clear also that for depreciation and appreciation, it's not two different formulas really, but the main difference is the sign, which, and in this case is subtraction for depreciation, and for appreciation it would be an addition of the percentage. So you don't have to remember two different things.
Similar.
Similar.
All right, but based on their meaning, we can infer, the sign that is appropriate.
All right, so when we would have simplified from our substitution, we should get $35,200.
And I want to point out something here, Latoya. Earlier, when we looked at the value that we were getting inside the bracket, so here we have 1 and we're subtracting 1,200, right?
Yes.
If we look, the result of that is actually 0.88. Now remember, we said that our initial value, our starting value, is represented by 100%. Or one whole, right? And this 0.88, I can clearly see that this is less than 1 whole. So that also gives me a clue that I'm expecting a smaller amount of money or a smaller value for this taxi.
Definitely.
So $35,200.
Nice. So basically then, we can say that when we are simplifying, when you would have worked out what's inside of your bracket and you get a value greater than 1, that's suggesting appreciation. So if you're doing
added on.
And if you get a value less than 1, it's suggesting depreciation. So you want to be
losing value.
You want to pay attention to your values when you're calculating. Just in case you would have accidentally used the wrong sign.
Definitely.
So to speak.
Or either press the wrong, maybe you have the right sign written, but when you're putting it on your calculator, you press the wrong sign,
And it happens.
It does.
Time is against us, clock is against us, we're trying to rush through the questions.
Exam, I know, right?
All right, so that means that our value for P is then $35,200.
Cool. Well, the dollar sign is on P too. So.
All right, so then the other part asks us to find Q. And what are we actually finding in Q is the rate of depreciation, yes?
Yes.
And so we're going to use our formula again, and then we would have substituted the values that we can identify from our table
Right.
We actually have in this case the future value, which is what we are usually trying to find.
Yes,
but in this case, we have it. From our table there, we can see that is $21,250. Put it right there. We also have our initial or present value, which is $25,000 straight from the table. We also have our N, which is 1 in this case. And our 1 inside of the bracket is always constant. And now we're seeing that we're going to find R from our formula.
Right. So we need to basically
simplify.
Yes, and we're trying to make R the subject, right?
Okay.
So as we look at that, we're seeing that 1 subtract R hundredths, let me say it like that.
Yes.
It's multiplying 25,000. So in order for me to get R by itself on one side, I really need to divide through. In other words, divide my left-hand side and my right-hand side by 25,000.
Yes.
All right? And that's how we got to that third line there in our solution. I hope our students are seeing that on screen now. So we have 21,250 being divided by 25,000. That's on my left-hand side. And of course, on the right hand, we have 1 subtract R hundredths.
Definitely, because the $25,000, which is currently on the right side, would have cancelled when we divided. It was
multiplying,
through.
So we divided it.
Right.
All right, so let's continue. Again, still on our mission to get R to be the subject. So we noticed there that we had a 1 being added on the right-hand side.
Right.
And so, you know, in order to ensure our equation, in this case, is balanced, we would subtract 1 from both sides, all right?
In our quest to making R the subject.
That's right. So that's how we ended up at that point. Now, we have a fraction, and we're subtracting 1 from that fraction. It makes sense for us to write that 1 as a fraction as well.
And from the initial, we were talking, and we said that that 1 is actually the initial, the whole of the initial value or the present value. And the present value in this case is 25,000. So representing our 1, it's 25,000 divided by 25,000.
So that's representing the 1 whole.
Yes,
then.
it is.
All right. And even if we didn't know that, we also could use the fact that the fraction there that we're supposed to be taking 1 from actually has a denominator of 25,000. And so my 1 needs to be written as 25,000 divided by 25,000. All right, so I think we're on our way. Okay. Notice carefully that we're subtracting a larger value here from a smaller value.
Yes,
and so notice here that the answer on my left-hand side is actually negative.
Yes.
Yes, 3,750 divided by 25,000.
I can assure you, Karima, that at least one person would have made the mistake to put the 25,000 first in the calculator, just because it's bigger. But we want to ensure that we're paying attention to what we're doing.
That's right. So, still not yet there where we wanted to be.
Almost.
And so we needed to, you know, get R. Remember, that's the aim, to get R by itself on one side. And so at this point, we need to actually multiply both sides of our equation here by negative 100. And you may
Why
be
not
wondering,
100?
But if I multiply by 100, I'm actually going to have negative R on my right-hand side.
Okay.
It could be done. It just means that I would have to now go and divide by negative 1 again. So to lessen the process, we decided to multiply immediately by negative 100.
And we actually want R and not negative R.
That's right.
All right. And then this is...
The rest is pretty much computation.
Yes.
All right. So and notice here, before you move on, we're multiplying a negative 100 by a value that's negative in the brackets, right? And so you notice that our R value here is a positive 15. All right.
But they didn't ask us to find R.
So
what this information is saying to us is that the yearly rate of depreciation is actually 15%. And by nature of that, Q is indeed 15.
That's
all right.
So let's stick to those letters that are variables that were used in the question.
Right. So here's a hack. When doing your questions, you want to write simple statements because remember, whosoever is marking a paper can't tell what you're thinking. So you don't want to leave it at 15 equal R or R equal 15 because the question asks you to find Q. So you want to write a little simple statements just to say to the person who is marking your paper, you know what you're doing, because you know what you're doing.
That's right.
All right, and then the final question asks, what is the value of the taxi after 2 years? And once again, picking out information from the table and substituting.
All right. So in this case, remember now, we were given, we're asked to find the value of the taxi after 2 years, which means in this case, our N now has a value of 2, right? We're still using our 12% as the rate of depreciation per year. And of course, the initial value or the present value is still $40,000, right? Of course, once again, remember I told you to pay attention to the result of what's in the bracket. And I'm noticing again, it's 0.88, showing me a value less than 1. And so I'm expecting the depreciation. A smaller value will pop up. Beautiful. Value after 2 years is $30,976. We looked at how to calculate the value of the taxi after 2 years.
Right.
And we would have used the formula and noticed that our N now had a value of 2. But there is an alternative method that we could have used. Remember now that this question started out by asking us for the value of P, which we already found, which is, of course, remember now, P is the value after 1 year.
Yes.
So we're saying that when we get to this question, we already know what the taxi value is after 1 year.
Right.
$35,200.
Yes.
So we can use this. We now know that this value is the starting value for the second year. And so pretty much we just need to multiply this value by that 0.88, right? And again, we're multiplying by a value less than 1. And so we're seeing the same answer coming up, $30,976. So both methods are actually taking me to the same solution, right?
Definitely.
And that's one of the things I love about math. There is no one route. You have
more than
different
one
routes to get to your destination.
But I just want to point out quickly though, Karima, if you just glance at the screen, you are seeing two values being multiplied by 0.88. And you might be wondering to yourself, but how they get the same answer and you're multiplying 40,000 by 0.8 and you're multiplying...
Hold up. Talk about that, yes.
I would just like to point out that there is an index here and it's actually 0.88 squared.
That's right.
Just want to zoom that in just in case for a minute you were glancing and you did not see the square there, okay?
All right.
All righty.
Beautiful.
So we had some questions for homework, but we have some time. So we're going to work question 1, but I'm going to implore you at home to work question 2. Put it on Facebook or Instagram, #ClassTime, TVJ Class Time, so we know that you did it, or comment on our YouTube page,
All right, so let's look at the question. A parish council recycles 42,000 tons of waste this year. The council aims to increase the amount of waste recycled by 8% each year. How much waste does it expect to recycle in 3 years' time? Now, as we look at the question, Latoya, I'm seeing the increase popping out at me. So it didn't say appreciate, but by reading the question, I'm seeing that this is actually a question on appreciation. All right, so let's pick out what we know. We know the present value,
which is
42,000 tons. We also know the R value, which in this case is 8%, or 8 for the R when we substitute in the formula. And our N value here is 3. So remember our formula for appreciation. If we want to find our future value, it's our present value multiplied by 1.
Plus.
This is appreciation, good. Rate divided by 100, and that's raised to N. So let's quickly substitute.
Power. So we're finding FV in this case.
And our rate here, 8. And our N is 3.
So I'm seeing in bracket we have 1.08. As our 8% is represented by 0.8.
Beautiful. And I'm sure that our students who are watching will be able to actually do this calculation. And once correctly done, you should receive or get an answer of, I think I want to double check this. All right, yes. 52,907. And I'm putting on my units.
Tons. Right.
All right. So in the future, after 3 years, so they started off by recycling 42,000 tons of waste, and this is a good thing, by the way, recycling. Let me just drop that in there.
I encourage you.
Right. And in 3 years' time, they're expecting, based on that rate of increase or rate of appreciation, they're expecting to recycle 52,907.9 tons.
You know what I'm glad about? That this question does not have money, which means that not all the time it's dollars.
That's right.
Because in this case, the unit is tons. And not dollars.
Also want to point out, as we just touched on question 2, there's something I just want to highlight. Earlier we spoke about N, not always representing years. I'm hoping that we can get that on screen. Question 2, right. If you actually scan the question, you would realize that this one, the time period is in days. So it's actually giving you a rate of depreciation per day. All right, so we would have pointed that out earlier, that the time doesn't have to be years. It depends on how the rate, is it rate per day or per year, or, you know,
what time. All right, so just to do a quick recap before we go, if you're just joining us, be not dismayed, you can catch us on YouTube whenever you have the time. And we were looking at appreciation and depreciation. Appreciation refers to something increasing in value over time, while depreciation refers to something decreasing in value over time. We also derived a formula with similarities for both. And when we talk about appreciation, tell them for us, Karima.
All right, so to get the future value, it's the present value multiplied by 1, added to R, which is divided by 100, and that's raised to the power of N. And as Latoya said, the formula, they are pretty similar. So for depreciation, where we had addition, we actually use instead a subtraction to show the loss of value.
All right, and that's all for today.